Welcome back, ladies and gentlemen. My name is Mr. Mtunzi. I am a physics tutor. And today I am going to be talking about radioactivity, a topic that is fit for those that are doing ordinary level physics. So, in radioactivity, I'm going to focus on half-life. So, we write half-life. First thing that we want to do today is to define what is half-life. Half-life is the time taken for a radioactive sample to decrease by half its initial value. The time taken for a radioactive sample to decrease by half its initial value is what we call half-life. And half-life takes the units of time. So half-life can be in seconds, half-life can be in minutes, half-life can be in hours, weeks, years. And today, we all know that the graph of radioactivity is a decay curve that I'm going to draw here so that people can understand the definition of half-life graphically. So we are going to have our graph here, and here there is number of nuclei, and here there is time. And the graph is like this. It's a decay curve. And we want to explain what is half-life graphically. So we are saying initially in the sample we had 1000 nuclei. Then after one half-life, they will have reduced to 500. So the time that we have lapsed within when it changes from 1000 to 500 is what we call T half. And when it gets to 250, it's also T half, the time that we have elapsed. 125 we also have T half. For the same radioactive nuclei, the half-life is constant. Let's say here, maybe the half-life was 2 hours. So we would expect after every 2 hours for the radioactive sample to decrease, like what we are saying. A question might come in the examination asking you to find or to calculate the fraction of the sample that remains undecayed after a certain time interval. So there is a formula that we use, which is a number of half-lives. T half is equal to time interval over half-life. In our lesson today, let's say we've got a radioactive sample whose half-life is 3 seconds. So we're saying T half is equal to 3 seconds. And then the question is asking you to find the fraction of the sample that remains undecayed after 9 seconds. So our time interval is going to be 9 seconds. Okay, so we will take this data and put it into our formula so that we get the number of half-lives that we have elapsed. So here we have a time interval 9 seconds divided by 3 seconds. So we're going to have 3 half-lives. So to find the number of, to find the fraction of the sample that remains undecayed after 9 seconds, we will say half to the power of 3. So if we say half to the power of 3, we'll get 1 over 8. So this is the fraction of the sample that remains undecayed after 9 seconds. So if we subtract 1 minus 1 over 8, we will get the fraction of the sample that will have decayed. So this one is undecayed. So you will find out that when you come across such questions, the first step is for you to find the number of half-lives, and then you take the number of half-lives and you put it as a power so that you get the fraction of the sample that remains undecayed. For today, I thank you. Let's meet on some other time.